Many conditional probabilities can be found using a table method. Here I've got an example. This is contrived. I just made up these numbers, so it's not anything that deals with an actual situation. But you can kind of see an example here where someone has a disease or doesn't have a disease, and they get tested for that disease using some tests. It's kind of like the idea of having, COVID-19 and then getting tested positive or negative for it. Now, these are not that. It's not this. This does not represent that data. It's just again numbers I've made up. But it's kind of like that sort of a situation where you may or may not have a disease. You get tested. If you test positive, you can have the disease, or you could not, which would be a false positive. And you could test negative, which means likely you would not have it, but there could be some false negatives as well. Okay, where you actually have the disease and test negative. And so you can kind of see how this breaks down now, where the two columns, you have the disease or not have the disease, and then the total on the end. So, of course, the 115 and the 5 add up, the 20 and the 160 add up, the 135 and the 165 add up, and the 120 and the 180 add up. Okay, so all these things kind of add up nicely. And then going down, the 115 and the 200 or 20, the 5 and the 160 add up. Okay, and so each box, each of these four main boxes here show the category. If you went in and got tested and had the disease, or had the positive test and had the disease, that's 115 out of the 300 tests. Okay, if they tested positive and did not have the disease, that was 5 out of 300 tests, and so forth. And so what you'll find, you'll see a lot of these sorts of tables, and you can find conditional probabilities and other probabilities based upon these tables. Okay, so let me go down the list here. I got a couple written out. Let's look at the conditional probability that you have a positive test, POS for positive, given that you had the disease, DIS for disease. Okay, so we're going to assume that you have the disease, and then you're going to look at the number of positive tests out of those. All right, so this is, again, assuming. This is the given. The second one is always the given. So you're given the disease, and you want to find the probability of a positive test. So given the disease, so of all the people who have the disease, there's 135 of them, right? So we're assuming that they have the disease, and out of those 135, 115 got a positive test. All right, so the probability of a positive test given that they had the disease, is 115 out of 135. And we can, of course, reduce that, calculate the probability. 115 divided by 135, math frac. That reduces down to 23 over 27. I just didn't want to do the arithmetic on that. And then, of course, if you divide that out, 23 divided by 27 as a decimal is about 85%, or 0.85. Okay, approximately 0.85. So that's the probability of getting a positive test given that you have the disease. Okay. Now, if I switch the roles, if you switch the two events, it actually can result, or often results, in a different probability. So if I said the probability of having the disease given a positive test, you have to look at the positive test row, of which there's 120 positive tests, and the number of people who have the disease in that row are 115. So if you assume a positive test, you say, well, I got a positive test, what are the actual chances that I have the disease? It's 115 out of 120 according to this data. And of course I calculate that, 115 divided by 120, math frac, and that is 23 out of 24. And of course that is approximately 96%, or 0.96, 0.9583, and so on. Okay, so you can see the two probabilities are different. The probability of having the disease given a positive test versus the probability of having a positive test given the disease are different probabilities. But now let's look at the probability of having both a positive test and the disease. This probability can actually be calculated in 3 different ways based upon this table. The most obvious and easiest one is to take the probability of both of them occurring, which is the 115, and dividing it by the total probability, which is, or the total number of tests, which is 300. Okay, so it'd be 115 over 300, and we can calculate that. We'll reduce the fraction down to 23 over 60. And of course, that as a decimal is about 38% or 0.38. Okay. Now that's the simplest way to calculate it. However, it is an and statement, and ands can be calculated by taking the probability of one of the events and multiplying by the probability of the other event given that first event occurs. So if you take the probability of a positive test, so the positive tests are over here, that's 120 out of 300, right? So out of 300 tests, 120 of them were positive. So that probability would be 120 out of 300. Now, the probability of the disease given a positive test, well, having a disease given a positive test. Well, given a positive test is going to be out of 120, and that's 115 out of 120, right? So the probability of having the disease given a positive test, 115 out of 120 positive tests actually had the disease. And when you multiply those two probabilities together, the 120s cancel, and you end up with 115 out of 300, which is what we had before, or approximately 0.38. Okay? So that's a second way to calculate. It's longer, obviously, but it is consistent with the formula that we have seen. Also, you could actually switch the roles of these. You could say the probability of having the disease times the probability of having a positive test given that you have the disease. Okay? So switching things around a little bit. Obviously, these individual conditional probabilities are different. We just found them separately up here. But when you multiply by the other one, by the positive versus the disease, you'll get the same answer actually, which is kind of interesting. So the probability of having the disease, there's a total of 135 people who have the disease out of 300. So it's 135 out of 300. The probability of a positive test given the disease, we said, was 115 out of 135. Again, you could cancel the 135s because there's one on top and one on the bottom, and you'll end up with 115 out of 300, which again is our 0.38, same probability that we had in the other two calculations. Okay, so you can see how the probability of both occurring can be calculated using either conditional probability, as long as you assume the other one first. So if you assume a positive test, then you do the conditional with the disease given a positive test, or you calculate the probability of the disease and then the probability of the positive test given the disease. And in either case, you get the same probability of both of them occurring together.